Namaste. Welcome to the Living Mountain Lab, aka LML at Godavari. Come, I will show you around. Oh, yeah, it's a long climb. Oh, Lara and Barsha are already here.
Namaste everyone, and welcome to the Dream Team at Isimot.
For the last 3 months we've been working on the hydraulic ramp pump.
And today we will be showing you how the Dream Team dreamt.
Let's go! Isimot is an intergovernmental organization focusing on mountain development and helping the people of the Hindu Kush Himalayas. We are now in LML, which is situated here at the foot of the Puchoki Hill, which is the highest hill in the Kathmandu Valley. We will now walk up the hill a little bit further to show you our project.
I'm Basil and I do mechanical engineering, and the project we worked on was actually quite different from what we presented in the Netherlands, because the problem we faced was not about water scarcity but water accessibility and water affordability. In retrospect, it's pretty logical, because the water that gets lost in the pump is just flowing down a river the whole day.
I'm Jacob and I study nanobiology. To access water, farmers need to pump it into the field. However, pumping installations can be quite expensive and hard to come by in rural areas in the mountains. Next to that, resources are scarce and farmers don't have a lot of money to spend. The pump we ended working on would cost about ₹500,000 to build and import, which is about €3,500. And our main goal was to greatly reduce that cost.
I'm Lara and I study industrial design engineering, and this is the pump we came up with. Not this one, but this one. That pump was ₹500,000 to make and import, and in this pump we focused to make it cheaper and more locally available materials, and this is our result.
To begin our project, we did some research on how a hydraulic ramp pump works, but also on the local market. We read a lot of papers on the hammering effect, which is what is used to pump the water. We also looked at videos of people building their own pump to see what materials they use. We explored the market to see what materials are available for us and what machines can be used. Once we did this, we could start designing.
So to make the pump cheaper and simpler, we decided to use PVC pipes instead of metal. We used PVC glue instead of nuts and bolts, and we went with a very simple one-way ball valve design which did not use any springs. We thought the springs might lose their strength after a while and become less efficient. Not only was the number of parts greatly reduced, but we also of course greatly reduced the price of both building and maintaining the pump.
When gathering materials to build the pump, we realized that there are no easily available balls that would both seal the waste valve and be heavy enough to open it back up. When we started testing, we found that the balls we had were indeed too light. As you can see here, Lara is opening the valve by hand, when the point of the pump was that it works without external energy. We then came up with a different but more rigid and less simple valve and tried it out. This ended up being an improvement to our design. Oh, hij gaat ontploffen. Yes!
Huh? Ja.
Ik doe het gewoon, wat een tering.
The problem was that we couldn't pump very high, nowhere near our goal. We were still happy because that meant the design we chose for our valves works, but we needed to improve the efficiency. Something we hadn't done a lot of was calculating, so in our last couple of weeks, we got to work. We did not have enough time to test the results of those calculations, but we believed that implementing them into the design would again improve the pump a lot.
in the future, once the pump is working as our providers would want it, the last and most important step would be the implementation in the field. We've already made flyers that explain how the pump works and how to build it, but we've had no contact with the beneficiaries. So that would be something that we would recommend to our successors.
Oh, sorry. I was thinking of the horrors of climate change. As we've already said, the pump that Isimont uses comes from Pakistan. That's not that far from Nepal, but it's still unnecessarily far. After visiting a lot of hardware stores in Nepal, we've come to the realization that you can do so much more than you expect with your local materials. So for me, frugal innovation is more about looking inwards and not looking beyond the horizon for your materials for your needed project. Thank you.
Hello, yeah, I was just working on these frugal solutions. As you can see, even here in Nepal, on a beautiful hill, we are working around the clock to bring high-tech solutions to rural areas, like solar panels, solar cookers, and solar dryers. Now we have made our contribution, and I am very happy that I can say that.
What I like about frugal innovation is that you can use common household items to make your product cheaper and simplify it. For example, in our hydraulic ramp pump we use things such as cabinet magnets and a sink drain. And what I like about this is that you can use these kind of items and keep your product design relevant, have high quality, and it will also stay useful.